Okay, on to the final part of this chapter, pulleys. Pulley questions are great. And in year one, you have two types of pulley questions, vertical pulleys and ones that's connected to the edge of a horizontal plane. So look at vertical pulley first in example 13. So we have two particles, P and Q, of masses 2m and 3m, are connected to each other by light and extensible strings at same accelerations, passing over a smooth fixed pulley. Okay, so we've got P of mass 2m, Q of mass 3m, and they are connected by light and inextensible string that stretches over, a bit of a monkey diagram here, over a smooth pulley. And smooth pulley means that the tensions in the string will be the same. So because it's a string, it'll be tensions. The tensions are going to point towards one another, albeit in the same direction this time, but they are still pointing towards one another. Tensions there. And the pulley is also going to be connected to the ceiling or connected to something above it. Okay, so we're going to have a weight of particle P dragging it down, so it's going to be 2 mg. Unfortunately, it looks like the Lagrange, but it's not. It's 2m times g and 3m times g. Now, this is held at rest, and when it's released from rest, common sense should tell you that this particle is going to be one that's going to accelerate towards the ground because it's heavier. But because it's a connected particle, the acceleration must be the same, albeit in the opposite direction. So if this accelerates down at a rate of 8 meters per second, this side is going to accelerate up at a rate of 8 meters per second. So in this question, what I need to do is, after it's released from rest, I need to write down an equation of motion for P and an equation for motion of Q. So if I just look at P first. Now I'm going to be using Newton's law, RF equals ma, but you always follow the direction of the acceleration. So for P, RF is going up. So that'll be all the forces up minus all the forces going down equals ma. So that will be T going up minus 2mg going down equals 2ma. For Q, on the other hand, if we just look at Q is accelerating downwards, so our resultant force for Q must be in the downwards direction. So that's down minus up equals ma. So we'll get 3mg minus T equal 3ma. And always look out for this on a vertical pulley question. You should have T minus and minus T. If you don't have that, something's gone badly wrong, you've made a mistake. Now, in order to work out the tension and acceleration, all I now need to do is add these two equations together, because then tensions will cancel, because you've got T minus T is 0. It's got minus 2mg plus 3mg is 1mg, or just mg. 2ma plus 3ma is 5ma. So you've got m's cancel, so acceleration must be equal to a fifth g, which will be 9.8 divided by 5, so that's going to be 1.96 meters per second. In order to work out the tension, I just need to substitute that back into either. Obviously, substituting the top one's slightly easier because it's T minus rather than minus T. So if I substitute the top one, T minus 2mg equals 2ma. Remember, A is a fifth G, so that's going to be 5G, so that's going to be 2/5 mg. So now that comes across as an add, T is going to be 2 plus 2/5, which is 12/5 mg. So I've worked out the acceleration and I've worked out the force exerted and the acceleration. I now need to work out the force exerted on the pulley by the string. Now the string is pulling down on the pulley. Both of these two weights are pulling down on the pulley. So you also get two tensions here pulling down on the pulley. So the overall force that stops the pulley coming down and crashing to the ground must be equal to 2t, which is what, 24/5 mg. Part E says that we need to, the distance moved by Q, and Q's moving to the ground, in the first 4 seconds, assuming that P doesn't reach the pulley. Because say after 2 seconds P hits the pulley, Q's going to stop because it's a connected piece of string. So assuming P doesn't reach the pulley in the first 4 seconds, Q's going to move downwards for 4 seconds. So it's going to be a CVAC question. So T is 4 seconds, acceleration is 1.96, release from rest, and we want the distance moved S. So formula hooks up S, U, I and T. S equals ut plus r flat squared. S equals ut, which is 0. Half A is 0.98 times 4 squared. So 0.98 times 16, which is 15.68. So I'm going to round that to 15.7. 3 sig figs. I did say if it involves G, you shouldn't go beyond 2 sig figs. You'll get away with 3 sig figs, but really I should put 16 to 2 sig figs. Last bit, state overuse the fact the pulley is smooth in your calculations. That will mean the tension is the same either side of the pulley.